Hello everybody, hope you're doing well and thanks for joining us for another video, where today I'd like to tackle claims that are knocking around from a few people who say that according to the heliocentric model, Mercury and Venus should not be visible in the night sky because they're meant to be between the Earth and the Sun. Now, I've seen a couple of variations of this claim, some people saying that neither should ever be visible, and recently someone was questioning if Venus appears higher in the sky than it's meant to based on the globe model. So in this video we'll go over why the heliocentric model predicts they would be visible at night, why their positions in the sky perfectly match the heliocentric model, and why they also help debunk flat Earth. Firstly, let's cover why they are visible at all. I think people seem to see basic diagrams like this of the solar system and presume that because Mercury and Venus are closer to the Sun than the Earth, then they must therefore always be on the daylight side of Earth, as such not visible at night, when in reality both can be seen just before sunrise and after sunset. Mercury about an hour either side and Venus about 2 hours either side. However, if we look at the heliocentric model, we can see how this is easily possible. For this, I'm using Universe Sandbox, which is a fun game anyway, where you basically get to play God with the galaxies, but it also offers us a great interactive view of the heliocentric model. Now, it's important to understand that on the globe model, the objects in the sky don't set because they are moving, they appear to set from our perspective because we are moving due to the Earth rotating. So, as your location rotates past the Earth's terminator line, you move into darkness, and this is where we see the sun appearing to set. So, if you're standing at the equator, your perspective is essentially rotated through 90 degrees, like this, and everything will appear to move straight down into the ground. Now, if we take a look at Stellarium, which is a tool used by thousands of astronomers and astrophotographers for seeing exactly where and when objects will be visible in the night sky, so it's definitely accurate, we can see that if we set our location to somewhere on the equator, that is exactly how the night sky appears to move. And time-lapse footage taken by people around the equator also confirms this. So sunset occurs when that location on the globe rotates past the terminator line and into the dark side of Earth. And conversely, sunrise occurs when that location passes the terminator line on the other side, moving into the lit up half of Earth. Now, the reason that we can see planets in the solar system is because of sunlight reflecting off them. But much like anything else, how visible they are depends on how bright they are compared to the ambient light around you. i.e., in a pitch black room, the light on your phone appears blinding, but outside in broad daylight, it's barely noticeable. Or just like how the moon always seems much brighter at night than when it's visible during the day. In reality, the same amount of light is reflecting off it, but our eyes are adjusting to different levels of ambient light, which then makes the moon's apparent brightness shift. So, even during the day, Mercury and Venus are still up there in the sky, but their apparent brightness is so dim that compared to the Sun, we can't perceive them when their position is near to the Sun. But because those basic solar system diagrams aren't accurate, and instead Venus and Mercury both are orbiting around the Sun as well, that means there are times in their orbits when they are essentially out to the sides of the Sun. When this happens is when they become most visible. When their orbits are trailing behind that of Earth's, our observer on the equator, for example, will see the Sun set, but Mercury and Venus wouldn't have yet. When this happens, the sky begins to darken as we move around to the backside of Earth, and Mercury and Venus then both become visible. Likewise, when their orbits are ahead of Earth's, as our location comes towards sunrise, they will come over the horizon before the Sun does, and as such will be visible in the morning. But neither will ever be visible in the middle of the night, and neither will ever appear high up in the sky. They always become visible as they're nearing the horizon. But what about the claim that Venus appears higher than it should based on the heliocentric model? Well, we can test this. Using Universe Sandbox, I ran its simulation until I found a point where Venus was roughly perpendicular to the Earth based on the Sun, and I landed on a date of October 31st, 2008. Now, we'll pull up Stellarium and cycle to that same date. And based on a location at the equator, Venus was becoming visible in the night sky around sunset with an elevation angle of about 34 degrees above the horizon. Now, if I take a screenshot of the Universe Sandbox model, and I set a line at 0 degrees from the Earth to the Sun, and I then rotate it to where Venus is, 34 degrees. So the heliocentric model confirms how Venus would appear 34 degrees above the horizon. Not only that though, but for fun, let's compare the other planets. Sandbox is showing Mercury being on the other side of the Sun. So does Stellarium. So Mercury would then be visible at sunrise rather than sunset. Mars is on the backside of the Sun, slightly to its left, so it wouldn't be visible at all. And that's exactly where Stellarium puts it. Jupiter's orbit is in line with Venus's relative to the Sun, which means it would be visible in the sky but at a higher elevation than Venus, and sure enough, there it is. Saturn's placed on the opposite side of the solar system, to the right of Earth, which, like Mercury, should then put it below the horizon by sunset, but becoming visible towards sunrise. Exactly where Stellarium shows it. While Uranus and Neptune are towards the rear left of Earth, so they would be visible during the night. Exactly as Stellarium shows was the case. So what we are seeing in the sky perfectly fits a heliocentric model. Fancy that. But we can go even further with this. At various times, all the other planets will appear through the middle of the night, but never Mercury or Venus. Explained with the heliocentric model by the fact that all bar those two are further away from the Sun than Earth, so Earth can move between the other planets and the Sun. Yet Mercury and Venus are the only planets we ever see passing in front of the Sun. We only see full phases of moons and planets at night because we are seeing the fully lit side of them. Now, the only times we are ever in a position to see that is when those objects are either directly behind us or on the opposite side of the Sun. But obviously, on the opposite side of the Sun would be during the day, so we could never actually observe them in full phase. And Mercury and Venus are the only planets that we never see fully in phase. Yet, if you observe them in focus through a telescope, or view images from astrophotographers, you can see that when we only see a crescent of Venus, it's much larger than when it's almost fully illuminated. Because in a heliocentric model, Venus will move towards its full phase as it gets to the opposite side of the Sun, whilst its new phase will be when it's on the near side, transiting in front of the Sun. Thus, it would then be much closer to Earth, and so it would appear much larger. Mind you, we know that Stellarium's data is accurate because thousands of people use it every single day to plan celestial observations. And if we use Stellarium but switch off the atmosphere overlays so that space remains clearly visible, we can literally see the dance that the planets are doing around the Sun and how Mercury and Venus never drift that far away from it. And how, if we compare the views between the hemispheres, such as a location in northern Norway versus southern Chile, they're flipped. Now, why would two different locations see that effect?
Because I was inverted.
It would be interesting to see a flat Earth model that can predict and explain the mechanics of how all of that would happen, but I don't think we should hold our breath. Alas, that is going to be it for this video. As always, feel free to leave your thoughts in the comments down below. If you've enjoyed this video and you haven't already done so, then please consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.